Welcome to Unit 1.2. We're going to talk a little bit about speed and velocity here today. So to do that, we need to kind of make sure we know all of our terms. When we talk about speed in physics, it's the idea it's a scalar. It doesn't have direction. It's simply how fast you're going. So speed is a scalar function, so number of miles per hour or meters per second. Velocity is the vector. It's the how fast you're going plus the direction. The way we write that is with a V with an arrow over it or bolded sometimes in textbooks. If you just write the lowercase v by itself unbolded or you have the absolute value signs around it, that's what we're looking for, is the speed. Now, we'll talk a little bit about the difference between instantaneous speed and average speed as we're moving along. That's more of a discussion for calculus. So when we're talking about speed, to actually measure something, to measure the speed of an object, you measure something that's changing over a certain amount of time. And that time we write as delta t. It's a time interval, the amount of time that the object is moving or that we're allowing it to go through there. So the average speed is the distance traveled divided by the time. The average velocity, because it includes direction, we have to worry about the displacement. So when something is changing direction, some of that velocity can actually cancel out. Some of that displacement cancels out. So the average speed just worries about how far the thing has traveled divided by time. And when physicists talk about average velocity, it's the overall displacement, how far the object's actually going, the distance from the starting point to the ending point, that straight line distance. Whereas the path length is the total distance traveled. So time interval can be longer or shorter depending on what's moving there, and you'll go different distances depending on how the time interval is measured. Most of the time when we're dealing with problems involving absolute or average speed, if it's going at a constant speed, that constant speed is distance divided by time, and I can rewrite that as distance traveled equals velocity of the average speed multiplied by time when it's going at a constant speed. It gets a little more complicated when we average multiple speeds together, but we'll look at that in class.